Hello everyone, welcome to 90-day crash course program. So today let's talk about physiology. So I'll be taking in sessions so that it will be easy for you to read and understand. So rather than spending 30 minutes or 40 minutes in a single video, so I'll just split into sessions so that it will be easy for you. So try to watch these videos whenever you feel tired or you want to refresh. You can just watch these videos so that your daily preparation goes on. At the same time, you are getting exposed to the previous year NEET and INI-CET MCQs. So without further delay, let's move on. So the first question is the organ of corti is a part of. So we all know that whatever we hear initially is received in the form of vibrations, right? So a person speaks, the vibration is received by the external auditory canal. It moves into the middle ear. It reaches the incus, malleus, and stapes, and later it is pushed to the inner ear, and through the cochlear nerve, it reaches the brain, and it is perceived as sound. This is the normal mechanism what is happening. So if you look at the inner ear, that is the cochlea, it has three layers. There is the scala vestibuli, scala media, and scala tympani. Okay, so these scala vestibuli and scala tympani, it has fluid in it. That is fluid, we call it as perilymph. Okay, it has perilymph. Whereas scala media, if you see, it has endolymph. What is this? It is basically a fluid which is very similar to ECF. Okay, so perilymph, if you see, it is rich in sodium, and endolymph is rich in potassium. Okay, so initially the vibrations which are perceived by the external auditory canal and the middle ear, it is once it reaches the cochlea, it is converted into fluid waves. Okay, so the scala vestibuli, which has perilymph, converts the vibrations which is pushed by the stapes into a fluid waves, and what happens is it is pushed via this yellow structure you see here. Okay, so the vibrations reach the scala vestibuli, it is pushed via the basilar membrane. The yellow structure what you see here is the basilar membrane. So the basilar membrane, it receives the fluid waves and it goes down, the vibrations goes down, and once the vibration reaches here, this portion, the pink portion, is called as the organ of corti. Okay, the pink portion which you see here is the organ of corti. So the vibrations reaches to the organ of corti via the basilar membrane. So once it reaches here, you see some follicles here, right? You see thin hair-like structures extending from the organ of corti into some other structure. Okay, so these are called as hair follicles. Okay, so we have two hair follicles. We have what is called as the inner hair follicles. We have what is called as the outer hair follicles. Okay, so the outer hair follicles are also called as the stereocilia. You would have heard of it, right? Stereocilia. So these hair-like appendages, hair-like structures, what happens once the vibration is received, they start to bend. So as I told you, scala media is rich in potassium. Okay, so once these hair follicles bend, that is these hair follicles, the outer hair follicles, they bend. Okay, they bend, and that is going to result in opening of potassium gated channels. So once the potassium gated channels are opened, that is going to result in depolarization of the hair cells. That is going to result in release of the neurotransmitter, what is called as the glutamate. So these neurotransmitter, that is the glutamate, what it does is, it is going to result in stimulation of action potential, which is received by the cochlear nerve to the CNS, where it converts these fluid waves and the vibrations into a sound. So this is what is normally happening. So the main function of organ of corti is it is where the vibrations and the fluid waves are converted into sound. How? By the release of the neurotransmitter. Because of the bending of the hair cells, potassium gated channels are opening, the depolarization of the hair cells occurs, that in turn releases the neurotransmitter which stimulates the cochlear nerve. Okay, so the organ of corti is basically present in scala media. So another one important structure is See, the air follicles, as I told you, it extends into some other membrane, right? That is called as the tectorial membrane. Okay, so any bending of the air cells over the tectorial membrane, that is the one that is going to cause the release of the potassium channels. Okay, so the potassium gated channels are open. So it is present between the tectorial membrane and the basilar membrane, the organ of Corte. So in general, if you see, it is present in the scala media. So the organ of Corte is a part of scala media. See, when you can rule out two options in a question, okay, when you can rule out two options in a question, 100% of the times you should attend that question. If you can rule out one option, try to attend at least 70% of the times. If you cannot rule out even one option, that is where you should be very cautious, because you have to mark that question for review, and then you have to think about whether answering that question or not. See, always remember, your first instinct 99% of the time it will be correct. Don't try to change that. Don't mark that question for review. If you can rule out two options and at that point of time you are marking the answer, then don't mark that question for review. Move on. Because if you mark that question for review, if you come back again you will try to change the option, which is going to be wrong most of the times. Okay, so moving on to the next question. Which of the following nerve fibers is more sensitive to hypoxia? What is hypoxia? Decreased oxygen at the tissue level. Okay, so am I right in saying that whichever fibers require more amount of ATP will be more sensitive to hypoxia? Obviously, see, say for example, I am a fiber, I need more amount of ATP for my function. Okay, I need more amount of energy for my function. So suddenly, if there is decreased oxygen, which in turn is going to result in decreased ATP production, am I going to get affected or not? Obviously, I'm going to get affected. So in that way, if you see, the preganglionic fibers, they are myelinated fibers. The postganglionic fibers are non-myelinated or unmyelinated. They are unmyelinated nerve fibers. And if you look at the dorsal column, it is just a pathway. Okay, this I can easily rule out. It is not related to, it is not a nerve fiber, it is a pathway of the CNS. And autonomic fibers, if you see, it is very, very broad, right? So I'm coming to either preganglionic sympathetic fibers or postganglionic parasympathetic fibers. So if you look at the preganglionic sympathetic fibers, as I told you, it is myelinated. What do you mean by myelination? See, myelination means a sheath is going to cover the axon. It is like a protection. Okay, so it is like a protection. Okay, you're going to see myelination here. So a sheath which is responsible for protection, insulation. So what is the main function of a myelination is, it is not going to allow the ions to stay there. Okay, it is going to push the ions to the nodes which is present. So imagine this is a node. Okay, so as we all know, myelinated nerves will have nodes of Ranvier. So this is the nodes. So what happens, because of the presence of the myelin sheath, it acts as an insulation material. The ions are not going to stay there. It is going to get pushed to the nodes. So because of this, what happens, there's going to be less energy consumption, because once the action potential is generated, I'm going to jump from here to here, to here to here. That is saltatory conduction. Right? That is what is happening in myelinated nerves. So I require less amount of energy, because I'm going to jump from one node to another rather than traveling throughout the nerve. Okay, imagine in unmyelinated nerves. So imagine there's an unmyelinated nerve, there's no nodes of Ranvier. So what happens, the sodium channels, they will be present throughout the nerve, throughout the axon. So what happens, more amount of energy is needed. because the sodium ions will be present throughout the nerve. So each nerve, each one should be activated. It requires more amount of energy for the conduction of the unmyelinated nerve fiber. Whereas in myelinated nerve fiber, there is a myelin sheath which acts as an insulating material. So it prevents the stagnation of the ions. It will push the ions to the nodes of Ranvier. So there's going to be saltatory conduction, jumping of nodes, less energy, less ATP conduction. So with this, we can conclude that the unmyelinated nerves, they are more sensitive to hypoxia because they require more energy because of the absence of myelin sheath. Okay, so the answer is going to be postganglionic parasympathetic fibers. Postganglionic parasympathetic fibers are unmyelinated nerve fibers. So moving on to the next question. Which of the following is not a crystalloid solution? Okay, so we must have heard of it. What is crystalloids and colloids, right? So basically, if you see colloids, they are larger molecules. Okay, colloids are larger molecules, and if you look at colloids, they can be albumin, gelatin. Okay, and we use colloids mainly for patients who has or had shock, major surgeries. Okay, patients who are undergoing major surgeries, patients who are having shock. So these patients we can give colloids. So colloids are larger molecules, whereas if you see crystalloids, they are smaller molecules. All these are crystalloids: ringer lactate, normal saline, glucose, all these. And colloids are albumin, gelatin, dextrons. Okay, so crystalloids, if you see, I can give in cases of diarrhea or any kind of burns, hypokalemia, okay, GI fistula. So these are all the situations I can give crystalloids. So crystalloids, the only complication what you can get in crystalloids is edema. Increased dosage can result in edema. Okay, whereas in colloids, increased dosage can result in coagulopathy. Okay, so crystalloids and colloids, larger, smaller molecules. Given in case of diarrhea, vomiting, burns, hypokalemia, crystalloids can be given ringer lactate, saline, or glucose solution. Colloids, larger molecules, albumin, dextrons, gelatin, they are given in major surgeries or shock. So more amount of colloids can result in increased coagulopathy. Okay, so colloids, if you see, they are predominantly present intravascular, crystalloids interstitial, between the tissue spaces, this in between the blood vessels. So this is the basic thing which you should know about crystalloids and colloids. So coming back to the question, which is not a crystalloid solution. So dextron is a colloid, larger molecule. Fine. Now moving